And hello, my fabulous students. This is your favorite teacher, Mr. Jacobson. I'm excited to be with you. We have entered into the Enlightenment period. So today we're going to talk about two things. We're going to talk about one, events that led up to the Enlightenment period, and two, the Scientific Revolution. So let us begin. So, science during the Middle Ages was much different from the Renaissance. And the reason being is because there were understandings in science that came from Greek and Roman writings centuries ago, and they weren't challenged. In fact, the Catholic Church pretty much just accepted all those writings, and anybody who tried to challenge those writings was also challenging the church because the church had accepted those writings. So you're going to see examples of that, and you're going to, as we've learned in the feudal system, people didn't challenge the church, and people didn't get to expand their minds as to other possibilities of why nature works the way it does. However, on the eastern part of the world, we have Arabic and Jewish scientists, and they are delving into mathematics, astronomy, medicine, and they're challenging old ideas. Thus, science continues to progress. However, it's just not progressing in Europe during the Middle Ages, but in other parts of the world. And then the Crusades came along, and Europeans were introduced to the works of Arab writings and scholars. The knowledge of the ancient Greeks had been preserved in the libraries of Moors and Cordoba, Spain. Remember, Spain was conquered by the Muslims for a very long time, and they don't really get control of it until like the 1500s or so. So European scientists learned about the scientific method from Arabic science. Advances in shipbuilding and navigation allowed European merchants and explorers to reach out and interact with other cultures. So it all comes down to the Crusades. We have these people who are now intermingling. The West and the East are intermingling. And with that, they're sharing technology, they're sharing food, they're sharing ideas, which is going to cause a flood of science and people wanting to understand how the world works. That idea is going to be emboldened in Europe during the Renaissance. So we have scholasticism, which was the dominant philosophy in the Middle Ages. However, rationalism is going to succeed. Rationalism, based on the teachings of ancient Greeks, became the main philosophical method of the Enlightenment. Rationalism is based on deductive approach. Deductive arguments begin with statements or premises which are assumed to be true. If the premises are true, the conclusion must also be true. So the Renaissance happens, and this is a reminder. I'm not going to read all this because we've talked so much about the Renaissance before, but you could pause it and absorb all that information. And so European scholars gained access to Arab and Greek knowledge in the 1400s. So in the late 1400s, we have the Christian nations defeated Muslim caliphate in the Iberian Peninsula. The Iberian Peninsula, if you can see here, this is the what is now known as Spain. Remember, King Ferdinand and Queen Isabella, they finally kick out the Muslims from the Iberian Peninsula, and they unite Spain once again. The Europeans gained control of 400,000 Greek and Arabic books, which had been housed in the libraries of Cordoba. So all those records that the Muslims were keeping in Spain, now the Europeans have those scientific records as well. So the Renaissance brought major changes to science. You have major people like Galileo. You have Avicenna, which was a Arabic physician, and his writings are now in their possession, and many others. Humanism emerged during the Renaissance. Though humanists believed that God created the world, they also believed that humanity could choose its destiny. Remember this idea that God, he was real, but he wanted us also to enjoy life, and we could make something of ourselves. And this wasn't just a place to suffer and then to go on to a better place known as heaven. Humanists supported education in the liberal arts like art, music, grammar, rhetoric, oratory, history, poetry, and used classical Greek and Roman texts. So now the scientific revolution. Now I'm not going to explain all this, but you can pause it and you can read it. This just gives somewhat of a little timeline about all the major breakthroughs and the popular figures in the scientific revolution during the Renaissance. And here's another slide that further continues the timeline. So empiricism. Empiricism is the method of investigation involving the use of senses. It doesn't rely on ideas alone, but instead uses direct observation. The scientific method is based on empirical testing of hypothesis and theory. During the Enlightenment, empiricism was developed by John Locke, who's this individual over here, who said that the mind at birth was a tabula rasa, a clean slate which is written upon by experience. Rene Descartes, he was in the 16th century a French rationalist philosopher and mathematician. Descartes believed that the senses alone were unreliable and advocated the use of deductive reasoning. He was a key figure in the scientific revolution. His book, Discourse of Method, provided a method for scientific research. So let's go over some of the four-step plans he had. 1, accept only that which you are sure. Divide your study into as many small parts as possible. Solve the simplest problems first. Make detailed lists of your work and results. Now, some of you might go, well, this is all very, very common knowledge, common sense, but it wasn't back then. It was called Laborium Prohibitorium, and this was a book that the Catholic Church put out, and it had the list of names of people whose works were to be censored by the church and would almost be classified as heretics. So let's look at some of these names. Here are some of them. And right away you can see Copernicus, you see Descartes, you see Galileo, you see David Hume, you have Immanuel Kant, John Locke, which these are names you're going to get more familiar with as we go through the chapter. So a scientific method is a system, a way to carry out research. Many of you are probably very familiar with the scientific method. You've probably learned this in your science class. This is where the scientific method is discovered and is proven. It's during the Renaissance and the scientific revolution where this idea that, you observe by searching for patterns, and then second, you make a hypothesis by formulating general ideas based on observations. And third, make predictions by stating what is expected based on the hypothesis. And step 4, experiment to prove or disprove the hypothesis. So Nicholas Copernicus discovered that the earth moves around the sun. Remember, people were still drawing upon Ptolemy's idea, and Ptolemy was a Greek Egyptian, and he believed that the earth was the center of the universe and everything revolved around the earth. Copernicus comes around and he says, nope, that is not what my findings show. So he was challenged by the church as well. But this is one of the first things, he's threatening the church's authority, and Galileo will continue his work as well. So Copernicus discovers, nope, the earth revolves around the sun. It doesn't matter what the church says. That doesn't change the fact, the reality that just because the church says it doesn't mean it does. So in 1660, 60 years after its original publication, the church banned Copernicus. And so it's De Revolutionibus, arguing that the idea of the earth revolving around an immobile sun was false and altogether opposed to the Holy Scriptures. We have a physician, his name is Vesalius. Now, he dissected corpses to study basic human anatomy. He is known as the father of modern anatomy. So during this time, we have individuals who are becoming very interested in the body and how it works. I believe it's Vesalius who even figures out that it's the heart that pumps blood, and that blood is actually circulating through our whole body with each pump of the heart. You have Galileo, who improved the telescope and supported the findings of Copernicus. Galileo built an improved telescope to improve the stars and planets. He observed that Jupiter had moons orbiting around it. The discovery that moons could orbit around planet went against the Catholic Church's belief that all celestial bodies revolved around the Earth. Galileo's direct observation gave support to the findings of Copernicus. So Galileo in his telescope, he's looking, he goes, wait a minute, I see planets revolving around Jupiter. Jupiter must have moons. And he said, well, if that's the case, and there are actual planets revolving around other planets, moons, per se, then the Earth cannot be the center of the universe. And so this was part of his deduction as he deduced that the Earth is in fact not the center of the universe. Galileo's findings were problematic for the church doctrine, and the Inquisition ordered him not to talk about it. The Inquisition was introduced by the Catholic Church during the second half of the 16th century to prosecute individuals accused of a wide range of crimes related to heresy. Remember, the Catholic Church has now had many people break away through Protestantism. And when that happened, the Catholic Church started creating what was called the Inquisition. They had a famous one in Spain as well. The Inquisition was to stop this heresy, stop this apostasy, and anyone who would challenge the church and the doctrines that they said were absolutely infallible and true, even if it was just scientists that were proving other scientists from the past wrong, but if the church agreed with that scientist, then they were proving the church wrong. The church couldn't separate the theology from the science. Isaac Newton was a physicist, mathematician, astronomer, alchemist, and philosopher. This is really an amazing individual. We're not going to go delve too deep into Sir Isaac Newton, but those who want to take you want to go further in physics and in science, you'll definitely learn more about him. Using intensive experimental methods, Newton discovered the three laws of motion and the universal law of gravitation. Newton's work is considered the backbone of modern mechanics. Newton's three laws of motion are the foundation of modern physics. First law, an object at rest remains at rest, an object in motion remains in motion. Motion does not change until a force is applied to the object. Newton's second law, the change in momentum of an object is due to the force applied to that object. The third law, for every action there is an equal and opposite reaction. Newton's discovery of the universal law of gravitation was said to have been inspired by an apple falling from an apple tree. So here you have, this is how the story goes. Story is pretty much accepted that Newton is sort of sitting on a bench and he sees an apple fall from the tree, and he somehow gets this idea that something must be pushing the apple down and thus creates gravity. So go ahead and write your one-page summary. I'm looking forward to discussing this with you at the beginning of the week. Thanks. Bye-bye.